Hi there, Vibe Gardeners. In this episode of Vibe Gardening Informed Edition, we're going to go over this other half of hydroponics 101 introduction. We're going to expand on the four pillars of hydroponics that make a hydroponic system work. So with that said, here we go. So to talk about hydroponics and what makes it work, we're going to go over quite a bit about chemistry, biology, and a little bit about physics as well. But just to let everyone know that I'm actually not that great at any of those topics. As a matter of fact, when I was in high school, I had to get my chemistry class evacuated at least once for mercury spill. Yes, that was me. And if I can make hydroponics work, I truly believe that the rest of you can get it to work as well. So with that in mind, let's go into how these systems work. So the first of the four pillars that we're going to talk about is water. Water, as we all know, is the main portion of hydroponics that makes it hydroponic, as in it is the base word hydro or water. And this is the thing that is for us here. We're talking about DWC or deep water culture. This is essentially the bedrock of everything is built on. And so the thing that we're going to talk about, starting to talk about here, is going to talk about something that I don't actually use to measure my water very much, but it's actually critical. It's EC, or electrical conductivity. This is essentially the measure of how much what's called dissolvable salt is in the water. Dissolvable salt doesn't mean it's actually table salt or sodium chloride. What that means is that it is a chemical salt or something that really kind of has reacted chemically and is in the water. And the basis of what we're basing this nutrition on is that we want to see how much actual solid is in the water based on how much electricity it conducts, which goes to our next topic, which is really ppm or parts per million. This is part of what's the total dissolved solid in the water. And essentially what this does is that it takes the electrical conductivity and it multiplies it usually by 500. There's actually two numbers, 500 or 700. 500 is the most popular and de facto one because it is essentially the same conductivity as table salt or sodium chloride. Now, some people use potassium chloride, which is 700, but unless they specifically identify it as anything else, it's usually a multiple of 500, which is standard for sodium chloride. And the thing that makes this important is that based on your baseline of what your water starts at, this is how you're going to be able to measure what is actually in the water. It doesn't mean that you know exactly what it's made of because that's based on what you put in there. But what it does, it tells you what's actually in there and how much of it is there. And the other important thing that we need to talk about is pH. pH is something that we talked about a little bit in my fourth episode on the basics of plant nutrition, or about NPK. And in that episode, we talked quite a bit about how pH affects absorbability of nutrition. But you got to remember that that episode is really based on soil, how pH affects soil. But here with hydroponic, when it's just water, it becomes a lot less forgiving, and because you don't have the buffer of soil, so that pH is going to highly affect how much nutrition is going to be available to your plants to absorb, and that is a big deal here that you got to pay attention to because without soil, like I said, it's less forgiving. You got to control everything. And so with all those things in mind, what water you use really depends on what's going on here. So in most cases, a lot of people I see online, what they do is they actually use tap water. And then also people like me will use RO water. And so tap water obviously is the cheapest and fastest way to be able to fill your system with. But you have to remember, this thing comes also with chlorine and other variants. That the chlorine is actually gasable. So if you kind of let it gas off, you will actually have a pretty stable solution to deal with. But there are another form of it, which I'll link below, that is not going to be exactly these. You can't really gas it off, and so you have to know what your municipal water really provides. If it's regular chlorine, you can just let it gas off and can use it. And the key here is you want to measure what the TDS or the ppm is when you first fill the system, and once you fill it, and then that will be your baseline. So everything else you add to it, is going to be on top of whatever comes with your tap water. But then again, because you're starting off with whatever's in tap water, and you don't have control what's in there, it'll interact in ways that you may not anticipate with the nutrition you add later on. And so that is the basics of choosing the tap water. But when it comes to RO water, it's not exactly easier. Just because it doesn't have any particles in it to begin with, they can go all the way down to zero. Like if you have the zero water filter, you can get the TDS down to 0 ppm, which sounds great in theory, but the problem is because they strip all the dissolvable solid out of the water, it becomes extremely wild in the beginning, which I've experienced quite a bit, in that I would take any nutrition in the very beginning when there's nothing in there. I'll put nutrition in there, and the pH, nutrition, everything just goes wild. And the reason for that is because there's no charge in the water from the solids, so anything would react to whatever in a different way, and that's going to give the pH a weird swing. It's going to give your a lot of nutrition going to get locked up because it's interacting with whatever is in there. So if you're going to use RO water, it's something I probably should do this time around when you do hydroponic system, is that I should probably use something like CalMag to get it, or calcium magnesium, and get the water up to about 100 ppm first to stabilize the system, to give it some kind of buffering, and then start adding nutrition, because that way I'm going to be able to avoid that wild ride in the beginning of the TDS. So with that said, I'll have a little image here of of what my continuous meter reads for my hydroponic. And as you can see, the thing it does is that it really shows ppm, and you can actually, in the app I have for it, it can show you if it's a 500 or 700 multiplier. And it's going to tell you the pH as well of the solution. It's going to have ambient temperature and humidity, which is where I'll show you once I start building a device, a system. But it's really one of those things that it's going to show. These are the key elements of the water that you want to be tracking to make sure that everything in the water is going to be right for your plant to do what it needs to do. Another thing about the water that you're using for the hydroponic system is that you want to make sure that you're changing the water regularly. Now, it's something I don't do actually at all. I only change my water for every crop rotation I have. So for every time I plant the seed until I'm done with that plant, or I'm going to discard it, I use the same tank of solution in there. That is something I'm able to get away with because I'm using RO water, or reverse osmosis water. And that to me gives me the flexibility of knowing exactly what's in there, how I'm introducing it, though sometimes you want to reset the buffer, but because I don't have that wild ride in the beginning, it's really not much of a huge problem for me. But realistically, if you can search online for what the experts say, but they all recommend you flush and reset your system every so often. But like I said, I'm able to get away with it, and I've seen other amateur content creators out there that also get away with it. So it's not a mandatory, but it's a good thing to practice if you want consistency in your hydroponic system. So if you survive through the whole water section of it, that's about, I would say, probably more than half this episode, because being hydroponic, it is the most important and heaviest topic in the whole entire 4 pillars. So the next topics we will get into are relatively short. So the first one we're going to talk about is air. Air, as we know from working with soil and plants in soil, is that if you don't give the soil enough air, the root will suffocate, and you'll get root rot, and the plant will die. This is the same concept here with hydroponic, though the whole entire root is just dangling in water here with DWC. But the reality is that just like aquarium for fish, because obviously they have to get air and oxygen into their system to survive, right? So what you can do, the same thing here, is you can introduce air and oxygen into the water to have dissolvable gas in the liquid. And just kind of like aquarium, you have basically two options. You can either use flowing water to introduce air, which is how nature does it, with a moving stream, currents and tide in the ocean and everything. You can do that with a water pump, or we can do, as you see with a lot of the other more pro aquarium setup, is that you can have air pump going through air stone and have these bubbles come up. And that sort of also how you would essentially make carbonated beverages. You can start getting that dissolvable gas into the solution so that the root will get the air it needs and not suffocate. And for me, I actually use both at the same time, because the advantage of having both is that the air stone gets you the air pump gets you the most air into the water, and then the water pump that circulates the water, not only does it get more oxygen and air into the water, but it also helps you circulate your nutrition and keep the system from becoming stagnant, which is going to be important as the water stay stagnant. If it stays stagnant, it's going to really promote algae growth and other stuff that I'll get into in the future when I talk about system builds. And it's just a great thing to have both, and that's why I do it for both my hydroponic systems. So the third pillar I'm going to talk about is nutrition, and that's something that, frankly, if you have gone through my plant nutrition 101, talking about NPK and stuff, that same principle applies. The big difference is that it's a lot less forgiving with water. Like I said before earlier in this episode here, that because soil does a lot of buffering, water does a lot less buffering. So you're in control of everything. You got to make sure that everything is stable. And this is also where pH becomes a lot more important, because, like I said, the lack of buffering, all that chemical reaction is a lot more readily available. And that's going to essentially create a lot more nutritional lockup that can happen if you're not careful with it. So just make sure you remember that through the stage of the whole life of the plant, you got to give it the right kind of nutrition. And this is where, because I'm usually doing mostly leafy greens, I only have one stage of nutrition I'm doing, which is more like a nitrogen heavy feed, like a 3:1:2 NPK ratio. And because of that, I really don't, this is why I don't have to reset my system at all through the whole life of the plant, because it's the same nutritional ratio the whole entire way through. So I don't have to worry about having to reset the ratio of the nutrition to make sure I'm triggering the next growth cycle of the plant. So the final pillar of the 4 pillars for hydroponic system is light. And this is actually very similar to basically any of the other stuff that we've gone through all season with growing, is that light is needed for photosynthesis, for the plants to grow, as we all know here. And so if you refer to my episode on explaining grow lights, whether they're a necessity or if they're a scam, it's one of the things that's going to explain to you the physics and science behind the light, and you will have to make sure you're getting the right type. For me, because I'm doing most of my hydroponic system in the basement where there's almost no light, I mean, there's very little coming through because of the tiny slit of window that's letting lighting. I'm going to have to use significantly higher wattage here. So I'm using about 150 watt shop light, and I'm basically just blaring down on it, and distance makes a big difference. And for a plant to get the correct amount of light, you have to understand how light decays, or as you get further distance from the light, how much light you're losing, the intensity of it. So remembering back to the grow light episode, the total amount of light a light source gives is what's called lumen. But the actual, at the point of wherever the distance is from the light, the actual intensity of the light in that particular location is called lux. And for the transition here, as this graph I'll show right here from basically a textbook called Calculus for Biology or Life Science. This graph has two graphs. Graph A shows essentially how quickly the intensity of the light goes down, where the lux level goes down as you get away from light. As you can see, it drops dramatically in the first portion of the graph. But then as you kind of get further away, it tails off into a flat curve. So this is kind of true if you think about your, like right now in my living room. If you're in my room, you look directly at the light, you see that the area around the light is the brightest. But then once you get away from the light for a certain distance, of course, the brightness drops significantly. But after that, it seems like the brightness doesn't drop nearly as much from that point, which is probably, I don't know, like probably 6 to 12 feet, or in this case, we're talking about like I think about 2 to 4 meters. I'm not 100% sure the conversion here. Once you get to that point, the light doesn't really drop off all that much for the rest of the room. So this is the graph that kind of shows that effect. And so if you're a math nerd, this is where you can realize it's actually what's called the inverse square, or it's 1 over distance squared. And so the graph B shows a correlation of converting from that raw value from graph A. And if you divide it by inverse square, and you will see that's actually a line graph, which if you know your calculus, that is actually a perfect correlation to what's actually going on in that graph. So this is how light decays. So with that said, you really want to make sure that you're able to move that light up and down as the plant grows. And that's going to give you the final pillar, the light pillar, and be able to give your plant what it needs to survive. So with that said, I hope that gives you a good foundation of the 4 pillars of hydroponics that I've discovered is critical for understanding and getting it right for me to keep my hydroponic systems running and keep the plants alive. So I hope that gives you quite a bit of what you need to get your hydroponic systems running correctly. And because it's, like I said, this episode doesn't show you anything but the fundamental 4 pillars. So I hope that taught you what you need. And with that said, let's keep gardening and let's keep vibing. Let's go.